Okay, we're going to try a video. We're going to try using DESMOS. If you're my online students, this may be new to you, but I want to go through DESMOS just so you get an idea. You're welcome to use the calculator or DESMOS on the next test. Why am I wearing a cowboy hat? It is homecoming week. So it's cowboy and rock and roll today. So anyway, here we go. Janisa scored an 88% on her stats test. Now, just because it says that's a percent, read more carefully. It says the mean is 82, so that's 82%, and standard deviation 5%. These aren't percentages they're giving us in terms of the normal curve. It's the percentage she scored, so this is just a z-score problem. So we're going to calculate Janisa's z-score, 88. And if you go to DESMOS, I'll start from fresh. Go to desmos.com, choose the graphing calculator, and then you can type things in the blank. If you're going to do the z-score, do 88, subtract 82, and divide by, I've already forgotten the standard deviation, so we will look again. Where is that? 88. Standard deviation of 5, we will divide by 5 and get the z-score. Z-score is negative 1.2, so you would do that same thing. That's Janice's z-score. Then the other z-score is for Ralph. He scored an 84 where the mean was 74 with a standard deviation of 8. So 84 subtract 74. And then go to the end of that, divide by 8, we get 1.25. Sorry, I got to put my glasses on, 1.25. So Ralph scored better. So on this one, I'll let you look to the answer key. I'm not going to write that down here, but you should state then Ralph scored better because he's farther along in the direction with what you would want to do. You would want to score higher on a test. Okay, now the next problem I will draw, but I'm going to show you the power of DESMOS on here. So if you're on DESMOS and trying it out, and I do recommend if you haven't, let's just X out of these. You click the little plus sign over here and you choose the inference. You see the little normal curve. Then you choose the probability distribution. When you choose probability distribution, you make your mean 0 and your standard deviation 1. We can change that, and we will as we go, but we create the distribution. What's nice about this is it draws the normal curve. So one of the points on the test, I don't want students to miss this, is always drawing the normal curve. So we have a normal curve, and let's see, read this again. Assuming a normal distribution, the mean is 26.3 with a standard deviation of 2.7. So I'm going to go in here and I'm going to show, we're going to change this right away. The mean is, so if you click on here on the normal distribution, it brings up the mean is 0 and 1. Hopefully that's showing on the screen well. And you put it, the normal distribution, instead of 0, 1, we're going to change it to 26.3 and 2.7. Now, on here, you'll see cumulative probability. Move your mouse on there and click on that. And then you have to think about the problem. If you're doing this problem, what is the percentile? The percentile is always the area to the left. So instead of having the region on inner, outer, or right, we're going to put it on left with the normal curve. But so far we don't see anything. So I'm going to hit the zoom button. The zoom over here, the little magnifier comes in and it gives us a curve. And it's shading to the left. That is the percentile. You know, so it's really nice with that. But we're going to change our problem. Our problem says that we're going to be left of 2.7, nope, sorry, 28. Sorry, I'm fumbling around with my words. So 28, and we put that in. Okay, so now I'm going to take this and we're going to make it a little bit bigger here with our screen. Hopefully, we've got, where's our, there we go. Okay, so if we're taking this, and that's kind of weird, all right. So It's a little confusing when it's like mirror imaging everything. But let's get this on here. The points that you would get would be for drawing the curve. And that is just too confusing, so I can't quite get this to work out. Does it flip the wrong way? Maybe that's the case. We're going to do this. Okay. So the points you would get, if you do the z-score, okay, I would give you the z-score, x minus the mean over the standard deviation. Whether you fill it in or not, I would like to see the z-score. I would give you the 1 point for that, but you can fill it in with the exact numbers and get that exact z-score. Then I expect the curve, and since we're dealing with the percentile, that's the area to the left. It was 27.3, and we were going less than 28, so the curve would look something like this. And the last point is the percent. I forgot to memorize it. Percent is the, and I also forgot whatever percentile it is the blank percentile. So this is the idea for the 4 points. One is for the z-score. I will take it with the formula. One is for the curve shaded in the correct direction. Then you take that answer, you put it in the blank, with the percentile being the context. Let's get back to the answer. Sorry, I didn't memorize that quickly. And hopefully, just to check something, I hope it's in the right image. If it did it in the backwards image, I apologize for that. But our answer on DESMOS comes up right away. It says it's 73%. So 73%, oh, not the percentile, is the percentile. 73% is the percentile that is less than 28. That would be our context. So here's a better idea of the picture, but the picture just, it comes so clear. And if you do it on here, it is a little easier, I believe, than the calculator, and it's a little more intuitive. Now, let's look at the next one. Autumn has a golden lab. The lab consumes 1.8 pounds of food per day. Typically, so this lab eats 1.8. Typically, that's the mean. The lab eats 1.4 pounds. If her lab is in the 90th percentile, what is the standard deviation? Okay, so the lab is in the 90th percentile. So this time you change it to bounds. Now, if you're using the calculator, you're using inverse norm. But bounds allows you to change this percent. So we can change that percent to 90%, putting 90% in that direction. But since we're doing a different problem, obviously, everybody, let's change this back. If you're new to DESMOS, change it back to 0, 1. And we change, we'll click the zoom button, and that's your z-score. The 90th percentile is a 1.282. You can click on here, even get more decimals, but 1.282 is the z-score. So if you wanted to do this the way that we've done this before, I'll do this, let's see, is it reading backwards? Just want to see, probably reading backwards. I can't tell if it's reading backwards or not. I think that's actually the forward way. So apologize. I think the last problem I did backwards. So here I'll try to squeeze it on. Maybe you can see it in the little window over here. So if I were doing this the inverse norm way, 1.282 is our z-score, equals the x, which is 1.8, subtract the mean, 1.4, and divide by the standard deviation. And you got to solve for the standard deviation. Well, you can do that, and actually we're going to have to do that this way to solve it, but we get our z-score from this. Since we don't have the standard deviation, we have to use the 0 and 1. 1.282 sigma equals 0.4, and we'll divide 1.282, and that's going to get us our standard deviation. Again, I didn't do the math on that, but that's how we will solve for that. Hopefully you're able to see that, even though it's in the little window. The idea, it's kind of hard because it mirrors the image. I will get the answer. The answer has got to be close to like 0.3, 0.4 divided by 1.282. You can click into another blank. 0.4 divided by 1.282 is 0.31. Should be the answer on that one. Hopefully I did that one right. Should really pull in. Let's pull up our answers for review number 1, just to make sure I'm on track. %, the last one, and this one is sigma equals, and I don't have an answer on there. That's kind of weird. Sigma equals, so we're going to go with that. I did that right. Whatever pounds, I'll have to fill that answer key in. So I'll have to update that. I guess I didn't have that one. It is 0.31 pounds. All right, let's look at another one. Salma is wondering if her trained cat can win the next competition. Typically, cats have a mean speed of 95 seconds, a standard deviation of 15. Assuming the normal distribution, Salma assumes that Snicklefritz can be 1.85 standard deviations below the mean, then he'll win the competition. How many seconds does he need to complete the obstacle course? Okay, so 1.85 standard deviations below the mean. If we were doing this problem, you would set up a z-score problem, but we're going to do this way. We're going to go with put it on area and 1.85. So we're going to put our z-score at negative 1.85. Now, since we could solve this, we could do the algebra, and we could solve this the old way. If you set up that equation, it'd be negative 1.85 equals, I'm going to set it up the way we usually would, x minus the mean. I'm showing the work on here. 95 and 15, x minus 95 over 15, and that's the way you would solve that. Now what would we do? We'd multiply by 15 and add 95. I don't think it'll solve that for us. So negative 1.85 times 15 and then plus 95, it'll do it that quickly. The answer is 67.25. But we can use the calculator and we can click up in here. We can put it on 95, comma 15, and then we can click our zoom, and it should have solved it for us. Why didn't it solve it for us? 95, 15. Oh, it's doing the probability. I'm thinking of something wrong. Oh, no, we have to, what am I doing wrong? Oh, because it's the z-score, there is no way we can do this with inverse norm or with normal CDF. We're stuck on this one. We have to do this using the z-score. So my fault on that. We can't use the inverse norm or the other one. We're going to have to do it the mathematical way to get the 67.25. My fault thinking we could. Okay, let's look at the next one, number 5. Assuming a normal distribution with mean of 92, standard deviation of 4.8, what percentage of values are between 90 and 95? Okay, we're going to do this one we're going to do it the long way, but I'm going to put it on inference again, probability distribution. If I go in, I'm going to set this right away. I'm going to put it on the mean of 92, standard deviation of 4.8. Now, since I'm setting the mean and the standard deviation, my cumulative probability, I'm going to put it on inner, which is in between two numbers, and I'm going to change those two numbers, and those two numbers are going to be 90 and 95. Now, what it doesn't give us it doesn't give us the z-score, but it gives us the answer. The answer is 39%. It gives us a great curve. So typically, I do want us to give the z-score, but if a student did this, they said it's z equals x minus the mean, I'm going to put m, over the standard deviation, and you use the symbol mu and standard deviation. I'm going to give you credit for the formula. There are two z-scores you would do. The two z-scores, z equals 90, subtract 92, over 4.8. So negative 0.41 is the first z-score, and 95, subtract 92, over 4.8. is the second one. So if you give the two z-scores, just make sure you give the answer in context. So we'll look what that looks like. That would be this right here. 39% is between those two. If you use the normal CDF function, that's okay on the calculator. It should give me the lower bound, upper bound, mean, and standard deviation. I will give you credit for this, or I will give credit if you simply state the z-score. Make sure the answer is in context. 39% is 1 point, that the data is between those two. All right, number 6. It says the top 7% is a value we're looking for. So I'm going to start again with DESMOS. I'm just going to clear out all these and X these out. I want to show you again the power with DESMOS. What I really like about this program, probability distribution. If you start with 0 and 1, you can always change it. But let's click cumulative probability and let's click bounds. Bounds is the equivalent of normal CDF if you're one of my online students using normal CDF. And for the bounds, I'm going to click the area on the right. Now, usually with normal CDF, we can't do that. But the area on the right is 0.07, and it gives us a z-score of 1.476. If you do look at the answer key, we get that 1.476 here. That's our z-score. And we are going to have that to do that. But we can let the calculator solve it, because in this problem, it says the mean is 82, standard deviation of 6.3. So if you write the 1.476 down, great, but the mean is 82. So we'll click in here with the mean and standard deviation. We'll type in the 82 and we'll type in the 6.3. And we'll click the zoom, and it gives us the answer. Our answer should be 91.3. It gives it right in there. You can click in it, get more decimals if you want. And that should be the answer that I have on the answer key somewhere, if I can stop clicking around on all these tabs. 91.3 is the top 7%. But notice it's shaded to the top 7%. Now, you can change that. You could change it to the left area and change it to the bottom 93. That's the same thing. That's the percentile. Typically inverse norm, you have to do it that way, but you still get the 91.3. If you switch it to area on the right, you have to change it to that 7% again. Can't be negative. I don't know how I hit the negative, but we get 91.3. So that's a little of an introduction to inverse norm. I hope that helps a little bit. Sorry, I fumbled around on some things, and this Screencastify program just wanted to get a video out there, so I introduce you. I'm going to try to do it for the other ones as well and get some more of these out there today. So thanks for watching the Screencastify video of inverse norm, how to use DESMOS a little bit.